Okay, I'm Professor Rajveer yaduvanshi from Netaji Subhash University of Technology. Today I'll be discussing about high gain dielectric resonator antenna in single unit, that is approximately 33 dBm in one single DRA. So this is an innovative article, and so far none has achieved this much huge amount of gain in one unit cell of DRA. Of course, using arrays this may be possible, but in single unit DRA so far it is not achieved. So it is a unique feature. What we want to discuss about is that dielectric resonator antennas are unconventional antennas. They do not use metallic part. They are purely based on the dielectric material which are being used to resonate at frequency, maybe L band, S band, C band, or even at millimetric wave. The basic unique property of dielectric resonator antenna is that they use dielectric material which are highly efficient, and they are temperature independent as against and they have huge amount of bandwidth as well as gain. But in this specific case we are dealing with an innovative approach to have high gain in DRA. DRA stands for dielectric resonator antennas. Here we have used rectangular shape of DRA, and inside that DRA we have used an air cavity, and the air cavity is used to have collimated effect or focusing effect or bunching effect, and because of this bunching effect the huge amount of gain is being achieved. Basic structure of this DRA is that it is a hybrid structure of air cavity and DR material, and this air cavity is being shaped in such a way that a collimating effect is being generated, and because of this collimating effect we are able to gain huge amount of gain. Here we have devised this particular DRA for Wi-Fi applications, and we are able to achieve with this concept more than 30 dBi gain. Then when we get 30 dBi gain in one single unit, it means if we use 10 such units in array pattern, we can get 30 into 10 or more than this much amount of gain, which was not possible earlier in small antennas. For the getting 50 dB, 100 dB gain, huge amount of structure of antenna were used. But in this case, very small compact insides will be able to get us the high gain. And the basic property of this is not active antenna, it is passive antenna. So being a passive antenna, the wonderful application which I am looking for is energy harvesting, where the huge gain is there in one single unit. If we have and that is passive antenna, so if we can form the array of such passive antennas, so the gain will be in multiplied form, and there is no active component involved. In specifically for rural area, we will be able to get the radio frequency energy harvesting with this type of high gain antennas. These are also known as high gain rectangular dielectric resonator antennas. So with this so far we are only able to design a high gain dielectric resonator antenna with waveguide air cavity loaded concept, and then this waveguide air loaded cavity is being used to couple DRA structure, and then DRA structure is used to radiate into free space, that is air, which has 377 ohm impedance. So initially the matching with waveguide is being performed and it is being loaded with air. So this is a unique concept by which we are able to get high gain dielectric resonator antenna. Further, one step ahead, we are going to club these high gain DRA antennas to form array of passive DRAs, and then these passive DRAs in array format will be used to harvest radio frequency energy from the ambient environment. So with this we will be able to get huge amount of DC voltage, maybe more than 10 volt. So this will be a wonderful application for supplying the IoT devices which are